Okay, let's try this problem. This polar curve is a little bit more trickier than the other one. So let's see what exactly this one entails. So the first thing that you want to go ahead and do is draw your reference graph. So remember that the 2 in front of the cosine means that I'm going to be multiplying everything by 2, and then I'm going to be shifting the cosine curve up 1 unit. So for the sake of time, I'm just going to go ahead and draw it here. Let me draw all my points first. So I'm going to have pi over 2, pi, 3 pi over 2, 2 pi. And if you forgot how to graph this, just pause the video, look up one of my other videos to see how to graph these types of trig functions, okay? So I'm going to graph it just regularly as if it was just a y equals 1 plus 2 cosine x. Okay, so what this is going to be, there's a point here, there's a point here, another point here, a point here, and a point here. So this would be if it was in the xy plane, but that's not quite the world that we're in. Okay, we're in the polar world, so we need to be able to graph it in polar coordinates. Now, here's a couple things that to notice at the graph. So a couple things to see is that the curve itself goes to 0 at 2 different points between pi over 2 and pi, and also pi and 3 pi over 2. So we need to make sure that we account for the polar graph at these 2 angles. I don't know what these 2 angles are. It's really, you don't really need to worry about these. Just know that r equals 0 at that point. So you need to make sure that you go back to 0 around these 2 points. So between pi over 2 and pi, this is going to be in quadrant 2. Between pi and 3 pi over 2, this is going to be in quadrant 3. Okay? All right. So let's go ahead and do what we were doing before. So we're going to start with theta equals 0. And when theta is equal to 0, my r value is equal to 3. Okay, so at theta equals 0, my radius itself is going to be 3 units. 1, 2, 3. All right, so here I am. Okay, so that's where I'm going to start. Okay, then let's go to the next one. Theta equals pi over 2. Okay, so at theta equals pi over 2, my radius in this case is going to be equal to 1. So at theta equals pi over 2, my radius is equal to 1. So this is just going to curve this way. Okay, something like that. Let me draw this a little bit better. Okay, that was worse. Okay. All right, whatever. It doesn't matter. Okay, so it's going to curve that way. All right. Then notice that we land in one of our red spots. So what you want to be able to do, so here's a weird angle. I'm going to just write weird angle. At this weird angle, which is in quadrant 2, my radius is 0. Okay, so this means that at some weird angle, I don't know where this angle is, somewhere there, is going to go back to 0. Okay. Okay. Now, after it goes to 0, now I can go to theta equals pi. And at theta equals pi, my radius is going to be -1. So remember, at theta equals pi, my radius is going to be -1. Now, this is not 1. This is not -1. We need to go to 1. This is where we want. So theta equals pi, I want to go to 1. Okay, that's going to be right there. Okay, that's -1. Or it's -1. Okay, then right before we go to 3 pi over 2, we have the weird angle again. So the weird angle in quadrant 3, the radius is now going to go back to 0. Okay, so this thing at some particular coordinate, I don't know what that coordinate is, this is going to go back to 0. Okay, there we go. Now we can go to theta equals 3 pi over 2. My radius in this case is now going to be back to 1. So at 3 pi over 2, my radius is equal to 1. So I'm back to 1. So now here I go to 1. And then finally at theta equals 2 pi, my radius is going to be back to 3. So at theta equals 2 pi, my radius goes back to 3. Okay, and that is my curve. So you have to be very careful with these, because if you don't account for these red portions, so for these things, your graph is going to look like this. And that's not quite what we want, because in here it actually has to loop. There's a loop here. So you have to be very careful when you're drawing these types of graphs. That's really what I have for you right now, but just be very careful when you have these types of polar curves.